Welcome back to the classroom. My name is Mr. Wong, and today we'll be looking at the 2022 24/7 Community Service Physics Question 1. This is going to be looking at Module 1, Inquiry Question 2, so kinematics, but we're trying to look at some vector analysis questions as well. So we have a projectile that's launched with an initial velocity of 15 meters at an angle of 30 degrees. So if we have a look, it says solve for the vertical and horizontal component of the projectile's velocity. So if we imagine we have a projectile, it's launched at 15 meters per second and it's launched at an angle of 30 degrees. We have two components. We have a horizontal component, we'll call that X, and we have a vertical component, we'll call that Y. Imagining that the resultant vector can be solved by two perpendicular vector components, we can solve for it using some very simple trig ratios. To solve for the Y component, we simply use sine theta. So it looks somewhat like this. So we have sine theta equals to y over the hypotenuse. Okay, so if we rearrange the equation, it becomes the hypotenuse, or the resultant vector, times sine theta. So it will be the y equals to 15 times sine 30 degrees, and that will give us our value for our velocity in the y component, which is 7.5 meters per second. And then if I want to find the x component, same idea, but this time we're using cos theta. So cos 30, and that would give us an answer of 12.99-ish meters per second. So I'll just leave it in two decimal places for both answers. So that's how you do part A. Part B, it says calculate the projectile's horizontal displacement. Assume that there is no air resistance. Okay, so if that was the case, and this probably is worth more than 2 marks, let's change that quickly. Okay, so let's have a look at this question here. Let's say it's about 3 marks. So the equation that we can use to find displacement is this one here. S equals to ut plus half at squared. Okay, the assumption is there is no air resistance. That means that there is no acceleration for the x component or the horizontal component. So if that is 0, then the formula becomes S equals to ut. Now I have u, I just worked that out. That was 12.99 meters per second. But I don't know the actual time that the trip of the journey goes for. So if I actually look back up here, let's make some assumptions here. So the only thing that's stopping our object, or the only thing that's causing our object to slow down as it goes up here, is gravity. And the only thing that's causing it to speed down is gravity as well. So what we know is gravity is acting on this ball at the same rate, which means that we can do a couple of assumptions. We can actually find the time taken for the ball to get from here to here and use that as the trip time, because the only reason why the ball falls down is because in the y component, gravity is pulling it down. Okay, so it's the y component that affects how long this ball will go in the air for. So at this very final point here, we have a final velocity of 0, but also here we have a final velocity of 0. When you reach the peak height, when you throw an object in the air, when it reaches that peak height, just momentarily, it will stop moving in the y component, as in it becomes stationary, which makes sense because if it's stationary, that's why we get this peak point here. So we need to find the time using the y component. So using y component to find time. So we'll label it as Vy equals to Uy plus AT. I know that Uy is 0. I know that, or Vy, sorry, is 0. I know that Uy is 7.5. I'm going to say that going up is my positive direction. Acceleration is coming down, so it's going to be negative 9.8 t. And so when I rearrange the formula around, t becomes negative 7.5, because I subtract the 7 over here, divided by negative 9.8. Okay, and that gives me a time. Let's see how long that takes. Of 0.76530.224. Now, one of the key points I want to highlight here is this is the halfway point, right? So this is the point it takes for it to reach this initial zero velocity. Because it launches and lands at the same height, that means the time it takes to get to here is just twice the time it takes to get to the peak height. So we just times or multiply our time by 2. So times t2, and we get a time of about 1.53062245. I'll round it off to 3 significant figures, or 2 decimal places. So that's the time we're dealing with here. Okay. Now we need to go back to the range here. So to find, let's change the color. So I want to find the horizontal displacement. Find Sx. Sx equals to ut. U was 12.99 times the time of 1.53. And we'll just do a round off in 3 sig figs here. So, or actually let's do it to 2 decimal places. Again, same like so. So 19.87 seconds, 2 deci places. And that's how you do question B. As you can see, it's quite a little process, so you'll need to try and work it out like so. And then our last one is calculate the projectile's maximum height. So we want to see what is this displacement at this point here. Well, we already know when it's in the y-axis, when it reaches peak height, its final velocity is 0. So we can actually use this equation, v squared equals to u squared plus SA or 2as. Okay, we could also use this one here, technically speaking, but as you can see, this is a square. We'd have to use quadratics, and that's quite fiddly. So if we don't really need to, we'll try and avoid using quadratics here. So I know that this is 0. This was 7.5 squared. That's 2. Negative 9.8. That's S. So S is equal to negative 7.5 square over 2 times 9.8 negative. Okay, Let's see what the maximum height is. So the maximum height I reach, again at 2 decimal places, is 2.87, or you could say 3 sig figs, that. But since I did everything in 2 decimal places in this question, I am going to leave it at 2 decimal places as well. Okay, so that's how you go through this question here. As you can see, there's quite a lot of steps. We went through the vector analysis first. Then the last 2 parts, we actually went back to the good old kinematics equations. Okay, so hopefully you found this video useful. If you did, please like and subscribe, and I will see you next time.